And what we're going to be talking about today is, the first slide we'll just cover some of the more common FIPS terms that we use here at wolfSSL, and a lot of terms that you'll hear if you're working with a lab or talking to a FIPS lab at any point. Then we'll talk about what is the importance of FIPS, what is the importance of having a specific operational environment listed on the certificate as a tested configuration, how to make sense of a FIPS certificate when you're looking at one and determine, what is compliant on that cert, what is actually certified and validated on that cert, etc. And then we'll go over how to read a security policy, how to tie a security policy to its CAB-P certificates and the role that the CAB-P certs serve, and then spotting any misleading FIPS claims early in the vetting process when determining if a module is sufficient for your FIPS requirements. So some of the more common terms, obviously FIPS stands for Federal Information Processing Standards. I assume you're all aware of that if you're attending this webinar. NIST is the National Institute of Standards and Technology, originally established in the early 1900s. They used to govern the manufacturing of farm equipment was kind of their first role. Their job was just to ensure that all the parts being manufactured for farming equipment was the best it could be. They didn't want, garbage going out onto these farms. That was kind of the advent of the NIST. And then, fast forward into the 80s and 90s, as cryptography was coming up, NIST was already a body that was doing standards for, by that time, many different assets of the industry across America. And so the federal government said, oh, we'll make them in charge of cryptography that will be used on the to secure data flowing over the internet. NIST saw this as a little bit too much for them to handle all on their own with all their other missions already going. So they established the CMVP, the Cryptographic Module Validation Program, which would be in charge of specifically validating cryptography in cryptographic modules. At the time, it was hardware only. The CPU capabilities at the time when the CMVP was stood up, you just couldn't implement crypto and software and have it run in any feasible amount of time. Like an AES encrypt operation might take, 7-8 hours to complete in software, where a hardware module could do it in just a few seconds. But eventually software did become more capable, and now today we have both software and hardware modules, and then we have an interim, it's called a hybrid module, which can be part software and part hardware combined together. The CMVP saw that this was a lot of work, a lot of responsibility, and they ultimately said, we can't do it all on our own either. We need this other body, the CAVP, and they'll be in charge of validating that the algorithms are running correctly. And then we, the CMVP, will just focus on the higher level aspects of the module, like, is it doing the self-test? Is it doing the compliance checks? Is it doing the pre-operational testing, the integrity check on the module, all that. The ACVP here, the Automated Cryptographic Validation Protocol, is more recent. So a few years back, the CAVP automated testing of the algorithms. And so now we use the ACVP protocol to talk to the CAVP's server. And you can get demo vectors without having a special certificate in place, but you can only get production vectors, what actually allows you to get an algorithm certificate by going through a third-party intermediary called a CSTL most commonly, which is a cryptographic security and testing laboratory. Here in our list, they're listed as NVLAP. So NVLAP is the National Voluntary Lab Accreditation Program. They're who accredits the third-party FIPS labs, the CSTLs, to be able to, review FIPS modules, to get those special certificates, to get production vectors and all that. SP is the security policy. UG is a user guide, and then OE is the operational environment. And the operational environment is a specific combination of a chip set or silicone or CPU, however you want to call it, plus an operating system and the module that's running on that operational environment. Now that is specific to a software module, and I'll be talking a lot of this stuff from the point of a software module. Here at wolfSSL, we make a software module. If this were a hardware module, the OE would just be, the hardware cryptographic module, and there might not be an operating system associated with it if it's all just being done in hardware. And then finally, the tested configuration is the OE description, plus you add an extra element, and that's the form factor that was used to do the testing. So on our next slide, why is FIPS important? For us as a software vendor, these are, views from our point as a software vendor. So FIPS is important. One, I kind of touched on it already, just to make sure that any module in use by the federal government, and I should have mentioned Canada is also part of this agreement and always has been since the beginning of the CMVP days. So any module in use by either the Canadian government or the US federal government, they wanted a way to guarantee that they were all using the most secure algorithms and that they could all talk to each other. For example, you might have one implementation of AES that has a bug in it. It can encrypt and decrypt its own AES stuff, but then if you pass it to another module that also implements AES and doesn't have that bug, the second module might not be able to decrypt the AES encrypted information from the first module. So interoperability, we'll just call it that. So that's the original main goal of FIPS, was to guarantee interoperability and use of the most secure algorithms as opposed to a weaker susceptible algorithm. As a software vendor, we see a high importance in FIPS because it can be easily disturbed. The cryptography can be easily disturbed by the silicon that it's running on. And we have real world examples of this. We discovered a hardware bug in one vendor's hardware that was corrupting the AES outputs. And we reported this bug to the hardware manufacturer. They were able to address it on their assembly line and get us new hardware within 2 months, and then we were able to complete that validation. But if we hadn't been testing, our module had already been certified at that point. We were just retesting it on a new operating system and a new silicon combination when we discovered that bug. So if we hadn't been actually testing it and we were just saying, hey, our module's already been certified, you're good to run it in this environment, it would have resulted in an unusable and non-interoperable deployment of our module. So that's why we see high importance in FIPS and specifically retesting each operational environment when the underlying CPU or silicon and the operating system are updating. We similarly saw an issue on an operating system when we were doing Windows for the very first time. They have this ASLR thing. It's address space layout randomization, where our integrity check couldn't pass. Like, no matter what we did, you just couldn't get the integrity check to pass because it took, imagine a cake, and that's our module, and then ASLR slices up your cake into many different parts and then scatters them all over in memory. And then at the end of each portion, it leaves a little jump address that says, if you're running this program and you get to this point, jump to this address to find the next or the continuation of the program in memory. And every time we set the integrity hash value for our module and then reran it, it would change because it was, each time you run the thing, it moves the parts around in memory, and you just couldn't get a stable sanity check on the module because of that. So again, if we hadn't been testing, oops, sorry about that. If we hadn't been testing the various OS differences, we wouldn't have been aware of this, even though our module had previously already been certified. And then finally, cryptography is easily disturbed by the tool chain that's used to compile it. And we discovered this in the transition from Clang 13 to Clang 14. There was a bug in the compiler that was optimizing out global variables. So you couldn't, as we were doing a SHA-256 final operation, the compiler was optimizing out the temporary hash value that we had up to that point through a series of updates. And then when we did the final hash operation, the hash came out as all zeros because it got cleared by the optimization settings in the compiler. Now, we did find a solution for this. It was just to immediately upon entry into the final operation, we just stored the existing temporary hash value in a local variable, and then we did the final operation on that local variable, and that would prevent the compiler from optimizing it out. We also discovered that if we turned on debug statements where we were printing out certain parts of the structures in memory, that would also prevent it. But then our customer would have had a huge log full of all kinds of debug information that would have been unreasonable for a production deployment. So again, had we not been testing each operational environment, we never would have discovered those things. Why is it important to have the OE on the cert? So we have talked to a lot of our customers now that have gone with a cheaper, more affordable, what's called vendor affirmation approach, where a software vendor will test maybe 5 or 6 operational environments, like some common Linux flavors, Mac OS, Windows, and then they'll just vendor affirm everything else. Once it's passing on the 3 most common environments, they'll just vendor affirm everything else, even if it's running on a different CPU. And what our customers have reported back to us in many cases is that when they go to bid on contracts with that type of solution, they'll actually end up losing out just due to the fact that it hasn't been as stringently tested. And I will grant them that this happens most commonly when the CPU has a glaring difference. Like if the tested configurations on the certificate say that they were tested on an Intel Core i7, but the contract being bid on involves an Intel Core i5 or an Intel Core i9, so it's not even the same family or generation of CPU, that's when they have the most issues. But there have been other stricter cases, a couple in the VA hospital realm, where even though they were bidding on an i7, there was a vendor affirmed i7, or sorry, a tested i7, and then a vendor affirmed Windows operating system on a similar i7. The VA rejected it, or rejected their bid, because the i7s the difference was an 11th generation and a 14th generation chip, and the VA just said it's not close enough. They're completely different microarchitectures. They need to be actually tested. So that's where we say, pay attention to that sort of stuff. It could be snake oil. But, if it isn't a more strict organization, you may not face that issue. All right, so to make sense of a FIPS certificate, I have a link in here. We won't click on it today. I did take some screenshots to include in the slide, but you can go look at this on your own time if you want. So when you pull up a certificate, you can start off by just searching all the validated modules. They do have an advanced search option where you can filter it by like certs that were good for 140-1, 140-2, or 140-3. You can include like revoked or now historical certificates in your search if you want to see old ones, or you can just focus on currently active ones that are not revoked and not historical. And then once you open a certificate, so in the old certs, they used to actually list all the algorithms that had been tested here, and they used to have links to the algorithm certificates. Unfortunately, with the new SP800 140VR1, which is the automated submission process, those are no longer being displayed here. Now, we do have statements from the CMVP through our CSTL that they are going to address this eventually, but it's currently not a priority. They don't see it as a problem because you can just open the security policy and you can look at the table of tested configurations. You can find the algorithm certificate numbers in the tables, and then you can go look them up manually. So it is a little bit of a pain right now, but eventually that should alleviate itself. On the certificate, you'll see some contact information. You can call someone directly. So our cert always has my CTO and our CEO listed. With their phone numbers, you can get a hold of us, or you can email our support at wolfSSL.com. And then if this was a cert that isn't ours, you'll find the same information. So you can always get a hold of someone to ask about a certificate if you need that. And then next to that field with the contact information, you'll always find a link to the security policy. So again, this is our newer Cert 4718, so it's not showing the algorithms or the tested configurations here. But if you open that security policy, you'll be able to find that there's tables within the security policy that list all that same information. Let's see, where are my notes here? SV has all the details about the module. Yeah, the tested configurations. If there's vendor affirmed OEs, they'll be listed in a separate table in the security policy. And they are clearly separated, so you can see what has actually been tested versus what is just being vendor affirmed and may or may not have been tested. You'll also find a table that includes all the supported algorithms. So if you're looking for a module that specifically has AES XTS because you need to work on data or encrypt data at rest, and you need to be doing it using the approved algorithm for data at rest encryption, you can go down to the supported algorithms table and just see, does that module have AES XTS in it? And if not, you can move on until you find one that does. Oh, I should also mention the security policy will also include details about how to use that module without risk of invalidating the certificate. Because there are ways, for example, if you're using OpenSSL or even our module makes it a little easier. OpenSSL has like some runtime switches where you can turn on FIPS mode, now it's approved, and then you can disable FIPS mode, now it's not approved. Our module is explicitly, if you're using our FIPS module, it's FIPS. There's no runtime turning off of the FIPS module. And then if you have a use case where you need functionality similar to OpenSSL's, we have some guides and some helpful information on how. So the way we approach it is FIPS is FIPS, you don't mess with it. And then you could deploy a second library that's non-FIPS, and then at runtime you can be loading your FIPS module, and now your application's using FIPS cryptography, and then you could unload that library and then load a non-FIPS version of the library if you need to switch to a non-FIPS mode. But the library the FIPS library from us will always be FIPS. You can't toggle it at runtime, and so the security policy will have details about that type of stuff in it. To determine if an OE was actually tested or just vendor affirmed, you can go down to the table I was just referring to. So in ours, it's table 6. It might be, you can put custom tables into your security policies. So while ours is table 6, it might be table 7 or table 8 in a different security policy. So just look for in the menu, the tested operational environment, software, firmware, hybrid, and that will take you to the table with the actual tested configurations. And then there's a second table, vendor affirmed operational environment, software firmware hybrid. And if that security policy is doing vendor affirmation, those operational environments that are not tested with a CSTL and have not been reviewed by the CMVP, those will appear in that second table. For ours, this always will just say NA. So this is a screenshot of our older certificate. This is what I was talking about. In the older certificates, we had the contact info here, the security policy here, and then up above, it would have links to all the algorithm certificates that we had done in support of that module, along with all the different module versions that had been through revalidation or validation. And then up above that table was all the tested configurations. So it was much easier. You just had to click on the cert number and go to it. You didn't have to open security policy to find all that information. Unfortunately now, yeah, it's just an extra step there until the CMVP fixes how the HTML is being updated with the automated submission stuff. All right, so once you get to the algorithm certificates, once you've located them and you want to check, does this thing have AES XTS, for example, there's these options right here, and they did get kind of snipped out in my screenshot, just trying to fit it on this slide, but there's a collapsed version, an expanded version, and then there's what's called an aggregated view. And then aggregated, so a lot of times we're testing, 20 different operational environments, maybe 50 different ones. Each one will get an entry, for example, for AES CBC. So if we had tested 50 different OEs, there would be one entry for one OE and an AES CBC, and then there would be 49 more just like that. If you click on the aggregated view, it'll shrink it down so there's just one AES CBC entry and then all the operational environments that have been tested with AES CBC there. So the aggregated view is a lot more friendly if you're looking at a set of algorithm certificates that has many different operational environments underneath of it. And what these are showing, these little lines, so this link on the older certificates would take you to that algorithm certificate number. And then you could tie from our list of versions that had been tested of our module, you could tie that to the version on the algorithm certificate. And then you could see that this module 4.3.2c specifically had ASCCM with these key sizes, these tag links, these IV links, payload length, AAD length, etc. And you can also find all that same information in the security policy under the approved algorithms table. But this is just a little bit cleaner view of it. So if you're trying to assess a module and get a feel for its capabilities, the algorithm certificates provide a cleaner way of viewing all that information. So identifying a fake FIPS claim. So like we make products that are not FIPS. And the reason we have this slide in here is we have had a little bit of issue now. In the past couple of years, some of our customers will buy wolfSSL. They aren't fully briefed on or knowledgeable about the FIPS program. And then they'll hear that we have a FIPS module, and then they'll have some customer that comes along and says, hey, do you have FIPS? And they'll say, oh, wolfSSL does FIPS. We bought from wolfSSL, therefore we have FIPS. So that's not true. So we make FIPS and non-FIPS products. The FIPS products are only deployed under commercial use. The non-FIPS products, you can download them off GitHub. They're open source, so someone who grabbed a copy of our open source module does not have our FIPS module. We'll just put it that way. So if you have someone coming to you claiming that they have FIPS because they're using our library, just ask them a few questions. You know, what's the cert number? What's the OE description of what you had tested? And does the OE that you're using it on appear on the FIPS certificate? Just those, you know, as you're assessing a module or assessing a bid for a project, just, yeah, do a little extra due diligence goes a long way. Then also check, you know, are the algorithms that are being used all certified? So there are a couple of our customers that have found ways of turning on, for example, like RC4. It's a really old legacy algorithm. It's outside of our module boundary. It's in its own isolated file. So they can compile our FIPS module, and then they can compile RC4 separately as a standalone binary object, and then they can put the two together into a library. Well, now it's using non-FIPS approved algorithms in conjunction with the FIPS module, even though we didn't approve it that way, and our user guide specifically says not to do that sort of thing. So double check what algorithms are in use. You just make sure everything's on the up and up, and that the module was constructed in the specified manner to be running in the approved mode of operation.